In this problem, I'm given two functions, f of x equals 3x squared minus 4 and g of x equals 5x minus 2. In part A, I need to find the composition f composed with g of x and its domain. And in part B, I need to find the composition g composed with f of x and its domain. So in part A, I need to find f composed with g of x, which by definition is just f at g of x. Well, we work from the inside out, so I'm going to take my definition of g of x and put it here. So that is going to give me f at, well, instead of g of x, I'm going to have 5x minus 2. So now I need to figure out what f at 5x minus 2 is. Be careful, I have x's here and x's in the definition of my function. Remember, these x's are just placeholders. So all I have to do is replace both of these x's with 5x minus 2. So that is going to give me 3 times the quantity. Well, instead of x squared, I'm going to have 5x minus 2 all squared minus 4. So now all I have to do is simplify this expression. There are several different ways of doing this. I'm going to do it the long way of writing 5x minus 2 times 5x minus 2. And then I'm just going to FOIL out the binomials. So I get 3 times the quantity. 5x times 5x is 25x squared. 5x times negative 2, negative 10x. Negative 2 times 5x, negative 10x. Negative 2 times negative 2 is positive 4. Don't forget now I have to close parentheses, minus 4. Collecting up like terms, I have 25x squared. Negative 10x and negative 10x is negative 20x plus 4 minus 4. Distributing in the 3 times 25 is 75x squared. 3 times negative 20 is negative 60x. 3 times 4 is plus 12, and don't forget the minus 4. So what does that give me? 75x squared minus 60x. 12 minus 4 is plus 8. So that is the definition of our new function f composed with g of x. And now I need to find its domain. To find the domain, we always look at the unsimplified version of the function. That is this step here. Well, this is just a polynomial. There are no x's in the denominator. There are no x's under an even index radical. So what is the domain of every single polynomial? It's all real numbers, otherwise known as negative infinity to positive infinity. Now in part B, I need to find g composed with f of x. So g composed with f of x equals, by definition, g at f of x. Again, working from the inside, I'm going to take f of x and replace it with its definition. So that is going to give me g at, instead of f of x, I'm going to put 3x squared minus 4. Now to evaluate this expression, remember these x's are just placeholders. So I need to replace both of these x's with 3x squared minus 4. So that's going to give me 5 times. Instead of x, I'm going to replace that with 3x squared minus 4. And then don't forget the minus 2 on the end. Simplifying, distributing in the 5 times 3 is 15. So it's 15x squared. 5 times negative 4 is negative 20 minus 2. Combining like terms, I have 15x squared, negative 20 minus 2 is negative 22. So that is the new function g composed with f of x. Now to find its domain, remember we always look at the unsimplified version, which is this one. This is just a polynomial, so the domain is all real numbers, otherwise known as negative infinity to positive infinity. And one last thing I want to do is compare our two answers. Did we get the same answer for each new function? No. So in this case, f composed with g of x did not equal g composed with f of x. And in general, composition is not commutative.